Our next speaker is Adeva-Bustos, who is a researcher at SINTEF. She works in applying and integrating quantitative methods such as multi-criteria decision tools to support sustainable management in regulated rivers with an end-user stakeholder focus.
Thank you. Okay, if it works, yes, I think so. Okay. Thanks for the introduction. So I'm going to present today. It's a bit different to what we have seen until now, but it's more an assisting tool, in this case, influence diagrams, and how you can use them to find or identify cost-effective measures. For example, if you need to implement fish migrations measures. Yes, so as all we know, this is a complex environment in a sense. How can we implement decision-making in topics related with the environment? There are, especially also because it's complex due to the different stakeholders and the interest that this stakeholder has. For example, we can have fishermen and recreational kayakers. We can have hydropower operators in your river. There is legislation that you might also have to fulfill. There is economic benefits, and there is also the preservation of the nature by itself. So when we need to make a decision, it is not easy to do this and to find an agreement. Luckily, we have some methods or tools. In this case, I will talk about multi-criteria decision analysis methods. And they are actually useful because you can integrate multiple criteria, include trade-offs. You can also have a stakeholder engagement, and also they include uncertainty and sensitivity analysis. Sensitivity, sorry. So more in detail, I will talk about the use of influence diagrams as one of these methods. And they are actually very useful tools because they have a graphical interface. They are flexible. They also are able to compare the multiple stakeholders' interests during the meetings. You can show the diagram and discuss about it. And also, it's easy to adapt if you have new data coming in or if there are new methods that you want to test. So this method was based in a method used before by Barton et al., and it was implemented within a European project, FitHydro. Maybe some of you know about it or have heard about it. And we also got a small funding from the Research Council of Norway to distribute this information also in a national conference and to the national and Scandinavian stakeholders. So this method was actually tried in 3 different test cases. And I will just show you as an example how we use it for Las Rives in France. And in this case, we were having the challenge of improving upstream and downstream migration for European and salmon. And the idea was to try to avoid that fish will enter the turbines and also to help fish finding the safe way upstream. So there was a set of different scenarios defined that include the former setup, also another scenario that has these dive turbines, as you see there. So they will be also more energy coming from the attraction flow that will be used in the bypass. There was also another scenario where they implement a new trash rack that was moved a bit forward. And in addition, they also have another dive turbine to increase the attractiveness also at the beginning of this bypass section and at the fish pass. So, yes. So, for example, this influence diagram will include the different mitigation measures. It will have the upstream effectiveness, it will have the cost, and it will have the downstream effectiveness. And at the end, we will have the stakeholders or the objective function. What do you want to get? As an example, yes, you need to find, of course, your indicators. How are we going to define effectiveness or efficiency? And this can be done through modeling, literature, monitoring if you have, and then we can choose different of indicators and obtain, for example, the attraction efficiency and also the passage efficiency. And you can do this to infer your probability and also do it for several species. So this is the network we built for last reefs with all the nodes. We see in green is for the upstream effectiveness, in blue downstream, and we also have the cost of the different scenarios. So I will just show you a bit detail about how do we define upstream effectiveness. And yes, to do this, we use indicators for fish passage and also attraction efficiency. So if you have a modeling of your fish pass, you can use the data to define the different indicators, what are the values under your different scenarios, and then we use what it was in the literature connected in the report of feed hydro that came to find if these values were within the preference range or not. For example, for this case, there was one within the preferable, one within an acceptable range, and one indicator that was outside of the preferable values. And for the salmon, it was one in the preferable and two in the acceptable range. So how do we actually combine all these indicators and these preferable into what is the passage efficiency? So I want you to focus on the flexibility of the model to use and define different weights, for example, and not that much in the numbers, since it is an example of this. So if you have 3 indicators inside your preference value, you can say you have a probability of the 90%, and then there is also uncertainty that will go into the other efficiencies. If you have 2 indicators outside the preference value, but within your acceptable range, it was the case of the salmon, then you will say 80% probability of being efficient, and the rest goes to the other 2. And if you have, for example, 1 outside, you can say that 1 out, all out, so it will be 90% probability of not being efficient, and 10% slightly. And this was when all indicators have the same weight, but you can also have different weights within the indicators. So if, for example, you have an indicator that is ranked as the lowest importance, still you might have that is high efficiency. But if one of these indicators is ranked as very important, that means that all your efficiency will be on the slightly or move down towards not efficient. So we also include the costs, and that we were having it for the production and also for the cost of the infrastructure for all the different scenarios. And we did the same for the downstream migration through modeling. I will not go in detail, but think about the same. Like of all the indicators, we found which were inside the range, which were not. So in the stakeholder objectives, you are able to define what is the objective. Do you want to find the least cost measure? Do you want to have the highest efficiency or a percentage efficiency upstream, downstream, or a combined effect? And we were looking at the combined effect. So here, I hope it shows, it is, it doesn't, but it was a video of how does the model look and how you can actually, maybe I can try from here. Yes. How you can find what is, this is the same probability for all of the scenarios. And now you try to find which one will maximize your objectives. So just by having all the nodes with the data you have been collecting, then you can choose also different species and do the same. So for example, you can choose eel, salmon, and check which one it is. I will just pass a bit forward. And then you can do the same for eels. And for example, what we saw, it was that with the eels, it was not intended, the fish pass, to be designed for upstream, so it was not effective at all for all of the measures, while for salmon it was, and also the downstream effectiveness, it was for both species. So, and just the last slide, I wanted to show that this is how all the networks looks when they are displayed. It looks complex, but in reality, if you have time in your project to discuss about it, it's a very good tool to go and find out what are we looking, does it make sense, is there a new scenario we want to try, is this data that we are looking something that makes sense, and usually what we have seen is a lot of involvement also from the stakeholders. They might think, yeah, this is not what we want to see, we want to put more interest in this, so it's easier to discuss and to talk about it. Okay, sorry. So as summary, so they are effective tools and valuable tools for decision making, and also they have they are good to visually represent and understand various interests and goals. And I hope you find it interesting, even though it looks a bit complex. If there is time to discuss about it, we consider it's a good tool and a valuable tool. Thank you.